On July 16, 1945, the New Mexico desert was forever changed. A blinding flash brighter than 1,000 suns illuminated the pre-dawn sky. It was the culmination of years of secret work, a testament to human ingenuity and a terrifying glimpse into the destructive power now at our fingertips. This was the Trinity test, the first successful detonation of a nuclear weapon, marking the dawn of the atomic age. But this moment, forever etched in history, was not the beginning of the story. It was the climax of a global effort known as the Manhattan Project. This endeavor, shrouded in secrecy, brought together the brightest minds in physics, chemistry, and engineering. Their mission, to unlock the secrets of the atom and harness its power. The stakes could not have been higher. World War II raged across the globe, and the outcome of the conflict, perhaps even the fate of civilization itself, rested on the shoulders of these scientists. The world was on the brink, and in the deserts of New Mexico, a new era was about to begin. The Manhattan Project, despite its name, spanned across the United States. From Los Alamos, New Mexico, where the first atomic bomb was designed and built, to Oak Ridge, Tennessee, where massive facilities enriched uranium, the project was a testament to wartime mobilization. Thousands of people, many unaware of the true nature of their work, toiled tirelessly toward a common goal. The clock was ticking, and the pressure was immense. The genesis of the Manhattan Project can be traced back to a letter penned by Albert Einstein, urging President Franklin D. Roosevelt to investigate the potential of nuclear weapons. The letter, drafted by Leo Szilard, a Hungarian physicist who had fled Nazi persecution, warned of the devastating power of nuclear fission. Roosevelt, recognizing the threat posed by Nazi Germany, authorized the creation of the Manhattan Project. What began as a small research program quickly ballooned into a massive undertaking, consuming billions of dollars and employing over 130,000 people at its peak. At the heart of the Manhattan Project was a collection of brilliant, eccentric, and often deeply conflicted individuals. Physicists like J. Robert Oppenheimer, the enigmatic and charismatic scientific director of the project, and Enrico Fermi, a quiet but brilliant Italian physicist, led the charge. Their contributions, along with those of countless others, forever altered the course of human history. Oppenheimer, often referred to as the father of the atomic bomb, was a complex figure. He was a brilliant theoretical physicist, fluent in Sanskrit and fascinated by Eastern philosophy. He was also a chain smoker and notorious workaholic, driven by the urgency of the project and the weight of its potential consequences. Fermi, on the other hand, was known for his pragmatism and experimental genius. He was the architect of the world's first nuclear reactor, Chicago Pile 1, which achieved self-sustaining nuclear fission in 1942, proving that a nuclear chain reaction was possible. The science behind the atomic bomb, while complex, hinges on a simple concept: nuclear fission. Imagine an atom as a tiny solar system with electrons orbiting a central nucleus composed of protons and neutrons. Fission is the process of splitting that nucleus, releasing an enormous amount of energy. This energy, according to Einstein's famous equation E/mc2, is equivalent to the mass lost during the process multiplied by the speed of light squared, an incomprehensibly large number. In a nuclear bomb, this process is initiated by bombarding a heavy, unstable atom like uranium-235 or plutonium-239 with neutrons. When a neutron strikes the nucleus, it causes the atom to split, releasing more neutrons in the process. These neutrons then collide with other atoms, triggering a chain reaction that releases an unimaginable amount of energy in the form of heat, light, and radiation. Harnessing this power was the challenge faced by the scientists of the Manhattan Project. Section 5. Trinity, the dawn of a new age. The culmination of the Manhattan Project was the Trinity test. In the pre-dawn hours of July 16, 1945, a plutonium implosion-type device, nicknamed Gadget, was hoisted atop a steel tower in the Jornada del Muerto desert. The scientists and military observers, their faces illuminated by the eerie glow of floodlights, waited anxiously for the countdown. The world held its breath. At 5:29 and 45 seconds a.m. local time, the device detonated with an explosive force equivalent to approximately 20,000 tons of TNT. The explosion vaporized the tower, melted the sand beneath it into glass, and created a mushroom cloud that soared miles into the atmosphere. The roar of the explosion could be felt hundreds of miles away. The Trinity test was a success, but it was also a stark reminder of the awesome and terrifying power that had been unleashed. Section 6. A World Transformed, the Nuclear Legacy. The impact of the atomic bombings of Hiroshima and Nagasaki on August 6 and 9, 1945 respectively, was immediate and devastating. The bombs, along with the firestorms they ignited, killed hundreds of thousands of people and left a lasting scar on the Japanese psyche. The use of these weapons hastened the end of World War II, but it also ushered in a new era, the atomic age, a world forever shadowed by the threat of nuclear annihilation. The geopolitical landscape was irrevocably altered. The United States, armed with its new weapon, had become a global superpower. The Soviet Union, initially caught off guard, raced to develop its own nuclear weapons, igniting a decades-long arms race that would define the Cold War. The world lived in the shadow of mutually assured destruction, a chilling reality where the survival of civilization rested on a delicate balance of terror. Section 7. The Shadow of Armageddon. The Cold War was a period of intense paranoia and brinkmanship, marked by proxy wars, espionage, and the constant threat of nuclear war. The Cuban Missile Crisis in 1962, in which the United States and the Soviet Union came perilously close to nuclear war, served as a stark reminder of the fragility of peace in the nuclear age. The doomsday clock, created by the Bulletin of the Atomic Scientists, became a symbol of this precarious existence, its minute hand moving closer to midnight as tensions rose and receded. Despite the ever-present danger, the Cold War also spurred technological innovation. The space race, a competition between the United States and the Soviet Union to achieve superiority in spaceflight capability, led to rapid advancements in rocketry, materials science, and telecommunications. These advancements, driven by the imperatives of national security, had far-reaching civilian applications, ultimately benefiting society as a whole. Section 8. The Unsettled Future of Nuclear Power. The end of the Cold War in 1991 brought a sense of relief and hope. The threat of nuclear war between the United States and Russia receded, but the legacy of the Manhattan Project lived on. The world still grappled with the proliferation of nuclear weapons, the environmental consequences of nuclear testing, and the challenge of safely managing nuclear waste. The specter of nuclear terrorism added a new dimension to the threat. Nuclear power, once hailed as a potential solution to the world's energy needs, faced renewed scrutiny. The Chernobyl disaster in 1986 and the Fukushima Daiichi nuclear disaster in 2011 highlighted the catastrophic consequences of accidents at nuclear power plants. While nuclear power remains a significant source of electricity in some countries, its future is uncertain. Section 9. The Moral Imperative. The Manhattan Project was a triumph of science and engineering, a testament to human ingenuity and determination, but it was also a sobering reminder of the destructive power of our own creations. The legacy of the Manhattan Project is complex and multifaceted. It is a story of scientific discovery, technological innovation, and the enduring power of human collaboration. But it is also a cautionary tale, a reminder of the devastating consequences of unchecked ambition and the moral imperative to use our knowledge wisely. As we navigate the challenges of the 21st century, the lessons of the Manhattan Project remain as relevant as ever. We must strive to harness the power of science for the betterment of humanity, while recognizing the potential consequences of our actions. The future of our planet depends on our ability to learn from the past, to use our knowledge responsibly, and to work together to create a safer and more just world for all.